Hi students, welcome to Sunil's tutorial. I'm Sunil Mirwani and today we'll be doing this chapter called as Atoms, Molecule and Nuclei. Let's see this. Take down the sum please. Calculate the de Broglie's wavelength. Calculate the de Broglie's wavelength of a 5 kilovolt electron. Calculate the de Broglie's wavelength of 5 kilovolt electron. Of 5 kilovolt electron. Hence find the corresponding wave number. Hence find the corresponding wave number. Formula 12.7 upon root of V into 10 raised to minus 10 meters. That's how you will get this. Potential difference is given to you. You can substitute the value of V there and you will get your answer, right? They have also asked you to find out the wave number. Wave number is nothing but reciprocal of wavelength. So you would have found out the wavelength from the previous formula. Hence you should be able to find the wave number. The answer for the sum should be, wavelength should be 0.1735 Armstrong units and wave number should be 5.746 into 10 raised to 10 per meter. Next, let's take down the next one please. An electron has kinetic energy. An electron has kinetic energy of 300 electron volts. An electron has kinetic energy of 300 electron volts. What is the de Broglie's wavelength? First thing that you need to do is convert this into joules. Once you've converted this into joules, then I need to find out the potential difference. Potential difference is nothing but kinetic energy upon the charge on electron. So in that case, you know the kinetic energy, you know the charge on electron. So this will be 300 into 1.6 into 10 raised to minus 19 upon 1.6 into 10 raised to minus 90. So you will get potential difference as 300 volts. Once you have the value of potential difference, then you can find out de Broglie's wavelength, 12.27 upon root of V into 10 raised to minus 10 meters. V you already have found out, so you should be able to get the answer. The answer for the sum should be 0.708 Armstrong unit. Next, take on next one please. Calculate de Broglie's wavelength of an electron. Calculate de Broglie's wavelength of an electron. Calculate de Broglie's wavelength of an electron of energy 400 electron volts. 400 electron volts given that H is 6.6 into 10 raised to minus 34 joule second and M is 9.1 into 10 raised to minus 31 kgs. Now guys, when the mass of the electron is given to you, in that case you will find out de Broglie's wavelength by using the formula H upon square root of 2me. mass is given to you, kinetic energy is given to you, Planck's constant is given to you, you should be able to get this answer. So all you need to do is just substitute, you will get your answer as 0.6144 Armstrong unit. Next, take down next one please. What is the de Broglie's wavelength? What is the de Broglie's wavelength? What is the de Broglie's wavelength of 2 mega electron volt photon, 2 mega electron volt photon, if the mass of the photon is 1.67 into 10 raised to minus 27 kgs. Mega, therefore multiply by 10 raised to 6, electron volts to convert into joule, 1.6 into 10 raised to minus 19. So that's how you will get that answer. Okay. Now they've asked me to find out de Broglie's wavelength. De Broglie's wavelength is h upon square root of 2me. Planck's constant we know. I can say where h is nothing but 6.63 into 10 raised to minus 34 SI units. So H I know, 2me, all the values are given to me. So all you need to do is just substitute and get the answer. The answer for this sum should be 2.028 into 10 raised to minus 14 meters. Next, take down next one please. For what kinetic energy of a neutron, will the associated de Broglie's wavelength be 1.4 into 10 raised to minus 10 meters. Be 1.4 into 10 raised to minus 10 meters if the mass of neutron is 1.675 into 10 raised to minus 27 kgs and H is 6.63 into 10 raised to minus 34 joule second. Now guys, we already know the formula for de Broglie's wavelength. I can say that de Broglie's wavelength lambda is equal to h upon square root of 2me. Therefore, I can say that lambda square is h square upon 2me. Therefore, I could say that, what have they asked me to find out? They've asked me to find out the kinetic energy. So, therefore, I can say that E is equal to h square upon 2m lambda square. You have h, m and lambda. You should be able to get the value of energy. Answer for this sum should be 4.18 into 10 raised to minus 2 electron volts. Next, take on next one please. The de Broglie's wavelength of a particle, of kinetic energy K is lambda. What will be the wavelength of the particle? What will be the wavelength of the particle? What will be the wavelength of the particle if the kinetic energy is k by 4? What will be the wavelength of the particle if the kinetic energy is k by 4? Now, we know that lambda is h upon square root of 2me. Therefore, I can say that lambda 1 will be h is constant, square root of 2 mass of the electron, mass of the given particle would be same, except that now the energy is going to be k by 4, right? Now in that case I can say that this is going to be 2, denominator of denominator becomes numerator. This is my lambda 1. So yeah, I'm just substituting. See, this is my formula. Lambda 1 will be h upon square root of 2m. What is the kinetic energy given to you? Let's call this as lambda 1, let's call this as lambda 2. Right, what is the kinetic energy given to you as k by 4, right? And in the case of lambda 1, this was h upon square root of 2m, kinetic energy was given to you as k, right? So in that case, divide equation 1 and 2. If I divide equation 1 and 2, I'll get lambda 1 upon lambda 2 is h upon square root of 2mk upon h upon square root of 2mk by 4, right? H and h gets cancelled, 2m gets cancelled, k and k gets cancelled, so I'll get square root of 4, which is nothing but 2. Now denominator of denominator becomes numerator, so I'll get lambda 1 upon lambda 2 is equal to 2, right? In that case I can therefore say, what have they asked you to find out? What will be the wavelength? The wavelength will be lambda 2 will be lambda 1 upon 2. Next,
lambda 1 will be lambda.
Next, take the next one please. Compare the de Broglie's wavelength of an electron. Compare the de Broglie's wavelength of an electron accelerated through a potential difference of 500 volts, accelerated through a potential difference of 500 volts with that of a proton of mass 1.67 into 10 raised to minus 27 kgs, moving with a speed of 0.4 c, moving with a speed of 0.4 c, if c is 3 into 10 raised to 8 meters per second. If c is 3 into 10 raised to 8 meters per second. Now, if the electron is accelerated if the electron is accelerated through a potential difference of V, then its speed is small v, then I can say that kinetic energy, that is half mass of the electron into velocity square of the electron, should be equal to EV. That means I can say that mass of the electron into velocity of the electron square is twice EV. So I could say that mass of the electron square, multiplying both sides by m, mass of the electron. So I had mass of the electron, I'm making this as mass of the electron square into velocity of electron square is 2 mass of the electron, charge on the electron into potential difference, take square root on both the sides. So mass of the electron into velocity of the electron is square root of 2 MeV. Right? Now why did I do this? Because I know my de Broglie's wavelength. I can say that de Broglie's wavelength, I can say that de Broglie's wavelength of an electron is lambda E is equal to h upon me into velocity of the electron, mass of the electron into velocity of the electron. Now in that case I can say lambda E is h, mass of the electron into velocity of electron, we have found out is nothing but square root of twice mass of the electron, charge on the electron into potential difference. Let's call this as equation 1. Now de Broglie's wavelength for a proton will be nothing but h upon mass of the proton into velocity of proton. Right? Now if I divide equation 1 and 2, divide equation 1 and 2, so I'll get lambda E upon lambda P is h upon square root of 2 MEeV upon h upon MP into VP. Right? So in that case you will get this as h and h is gone, so I'll get lambda E upon lambda P is MP into VP upon square root of 2 MEeV. Now let's see what are the values that I know. I know the mass of the proton, I know velocity of proton is given to you as 0.4 c. Mass of the electron I know is 9.1, where I can say mass of electron is 9.1 into 10 raised to minus 31 kgs. Charge on the electron we know is nothing but 1.6 into 10 raised to minus 19 coulombs. Potential difference is given to you. You could substitute and get this answer. Right? The ratio, this answer should come out to 1.66 into 10 raised to 4. Next, take down next one please. A proton and an alpha particle, a proton and an alpha particle are accelerated through the same potential difference. A proton and an alpha particle are accelerated through the same potential difference. Find the ratio of their de Broglie's wavelength. Find the ratio of their de Broglie's wavelength. Now see, if they are being accelerated, they will possess some kinetic energy. Right, now what is the particle? Any particle accelerated will have some kinetic energy. From where does it acquire kinetic energy? It acquires kinetic energy due to the charge and the potential difference applied to it. Right, therefore I can say that mv square is 2qv. Multiply both sides by m, so I'll get m square v square is 2mqv. Take square root, so I'll get mv is square root of 2mqv. Right, once I have this, then I can say that, but what is mv? mv is nothing but the momentum of the particle, so therefore I can say momentum is square root of 2mqv. Right, once I have this, then I can say that de Broglie's wavelength lambda is nothing but h upon momentum, where h is Planck's constant. So what we understand is that de Broglie's wavelength is inversely proportional to momentum, right? So in that case you could say that they have said that a proton and an alpha particle, so wavelength of proton to wavelength of alpha particle will be nothing but momentum of alpha particle upon momentum of proton, right? Now momentum is nothing but square root of 2mqv, so that means this is going to be equal to momentum of alpha particle will be twice mass of alpha particle, charge on alpha particle into potential difference upon square root of twice mass of proton, charge on proton into the potential difference. Now they've said that the alpha particle and proton have been accelerated through same potential difference, so we will get cancelled. So in that case I will get square root of mass of alpha particle into charge on alpha particle divided by mass of proton into charge on proton, right? Now, but we know, guys, that the charge on alpha particle is nothing but twice the charge on proton. Proton is nothing but a hydrogen atom. Alpha particle has twice the number of electrons as that of hydrogen atom. Therefore, I can say that Q alpha upon Qp is 2. We also know that the mass of alpha particle upon mass of proton is nothing but 4. Right? Alpha particle is nothing but fast moving helium atom. So its atomic number is 2 and atomic mass number is 4. Whereas hydrogen, proton is nothing but hydrogen, whose atomic number as well as atomic mass number is 1. Right? Now if I substitute these values, I will get the answer as lambda p upon lambda alpha is nothing but mass of alpha upon mass of proton is 4 into charge on alpha into charge on proton is going to be nothing but 2 square root, right? So lambda p upon lambda alpha is nothing but square root of 8, that is 2 root 2. So answer will be 2 root 2, right? Next, take on next one please. Calculate the voltage to be applied. Calculate the voltage to be applied. Calculate the voltage to be applied to an electron microscope. Calculate the voltage to be applied to an electron microscope so as to produce electrons of wavelength electrons of wavelength 0.6 Armstrong unit 0.6 Armstrong unit. Also calculate the speed of the electrons. Also calculate the speed of the electrons. Also calculate the speed of the electrons. Guys, de Broglie's wavelength is 12.27 upon square root of V, right, electron volts, because here this can be written as so many electron volts. In that case, I can say that V is nothing but 12.27 upon lambda the whole square, to get rid of the square root sign, right? I could substitute the value here and get this answer. This will be nothing but 12.27 upon whatever is the value of lambda, that is 0.6 into 10 raised to minus 10. So you will get your potential difference there. Next, let us assume, let V be the velocity of the particle.
What about EV?
Excuse me?
What about
EV. That's just unit I've written. Right? Now, let's see this. If V is the velocity of the particle, then I can say that kinetic energy that is acquired by the particle is nothing but equal to EV, charge into potential difference. Therefore, I can say that mv square is twice EV. So in that case, I could say that velocity is nothing but twice EV upon m under root. That will give me the velocity of the particle. You know the charge on the electron. The charge on the electron is 1.6 into 10 raised to minus 19 coulombs, and mass is nothing but 9.1 into 10 raised to minus 31 kgs. Right? So you could substitute these values and get the answer. The answer for this sum should be potential difference is 418.2 volts and velocity is 1.212 into 10 raised to 7 meters. Right? Take down next sum, please. What voltage must be applied to an electron microscope? What voltage must be applied to an electron microscope to produce an electron of wavelength 0.4 Armstrong units? If the charge on electron is 1.6 into 10 raised to minus 19 coulombs and the mass of electron is 9.1 into 10 raised to minus 31 kg. Now guys, we know that de Broglie's wavelength is h upon square root of 2 MeV, right? Therefore I could say that lambda square is h square upon 2 MeV. Therefore I could say that potential difference required is h square upon 2 Me lambda square, right? Wavelength is given to you. All I need to do is just substitute the values. That will tell me what is the potential difference required. answer for this sum should be 943.4 volts. Right? Next, take down next sum please. Find de Broglie's wavelength of an electron. Find de Broglie's wavelength of an electron moving with a velocity of 1.5 into 10 raised to 8 meters per second, having a rest mass of 9.1 into 10 raised to minus 31 kgs. If the velocity of light is 3 into 10 raised to 8 meters per second. Now guys, relativistic mass is nothing but m0 upon square root of 1 minus v square upon c square. I know v and c, both the values I know. So velocity square upon c square. Once I know the mass, then I can find out de Broglie's wavelength, which is going to be nothing but h square upon mv for an electron. Right, h is Planck's constant, which is 6.63 into 10 raised to minus 34 joules second. Right, so I could substitute the values and get the answer. The answer for this sum should be 4.206 into 10 raised to minus 12 meters. Right, this finishes this chapter. We'll stop this here for the day. Thank you very much.